This is a October 2024 42 variant and complete mechanics paper. We are going to start. So concentrate question number one. If you read a question carefully, then I think I just tell you what is the important thing here. This decelerate 5 by 3. So it means this deceleration is equals to 5 by 3. So A is equal to minus 5 over 3. And then he said for the first around about 6 seconds. Okay, this is 6 seconds he talked about. Okay. And then travel back to O. Do you know, student, this I discussed many times, but I repeat again. When particles going away from you, from observer, velocity positive, coming back to the observer is velocity negative. I believe the point is very clear. So this distance is while going away from the observer, and this distance is traveled while coming back to observer. So I think the idea is very clear. Okay, so have a look now how we can do it. So this deceleration can help us to solve the answer. What are coordinates here? 4 comma V, and this is a V. All right. And what are coordinates of this? Time is 10 and velocity is 0. So what is the given formula? Y2 minus Y1 over X2 minus X1. And you know velocity time graph, acceleration. So I'm starting from here, 0 minus V, or I start from here, V minus 0. So no problem. V minus 0 over 4 minus 10. And same time, I'm putting the acceleration value is negative 5 over 3. So now, so this is a negative 6 multiplies there. So negative 5 over 3 into 6 into not 6, negative 6 is equals to V. And the 3 2s are, and I got a 10. So Alhamdulillah Rabbil Alameen, 10 meter per second is my answer. So let's talk about total distance traveled by the particle 0 to t in 68. He mentioned that total distance from here till here is 68 meters, find t. Basically, this distance is a positive and this distance is a negative. Reason is very clear, is a below x-axis. So how to get this distance? So we half into base into height. Base is 10 and height is a V. So I'm writing here half into base into height. And V, I got it 10. So let me recheck. Yeah. And plus, when you talk about the other paragraph, what is this one? So this is a T minus 10 because this T and this 10. And what is this height of triangle? That is a 3. Don't take negative 3. So half into base into height. And base is a T minus 10 and height is a 3 equal to 68. And that's simple. This I got a 5. I got a 50 from here. And this is a 3 by 2 and T minus 10 equals to 68. 50 goes there and I got a 18. And rather than multiply inside, I bring this on the other side. So T minus 10, 18, 2 by 3. And 3 9s are 18. I got 18. And wait a minute, 3 6 are 18. 3 6 are 18. And I got a 12. So T minus 10. And finally, I got a 22 seconds. So Alhamdulillah Rabbil Alameen. I believe the point is very clear. And first question is completely over. Question number 2, we have a block of mass 20 kilogram. And best way to do the question is read and write. Okay. And rest at the top. So starting velocity is 0. Angle 30, block is projected speed of 5. Not 0, sorry, speed of 5 because it's thrown downward, speed of 5. And there's a friction resistance force acting, okay. And block moves 2 meters downwards. So distance is traveling is 2 meters downwards. And the work done is against is 50 joules. So work done against friction is a 50 joules. This part is clear. And we need to find out speed of the block when move to okay. So last velocity we need to find. So have a look now. I'm going to start. Bismillah ar-Rahman ar-Rahim. Okay. I'm going to make a triangle. You can see. And this height is important to know. This is a 30-degree. Particles traveling from top. And it's traveling towards down. So there's a here. And there's a 2 meter distance. Okay. So first of all, I want to find height. So opposite by hypotenuse is equal to sine 30. and sine 30 is half, h is becoming 1 meters. Okay, 1 meter. Now we have to apply, find the all values. What is kinetic energy on a top? So kinetic energy at the top, T for top, is a half mv square, mv square. So I got is 10 and I got 25, so 250 joules. Kinetic energy at the bottom, so half mv square. Mass is a 20 and v I don't know, so I got a 10 v square joules. Now I will go for potential energy on the top. mgh, mass, g is 10, height I just got it 1, so I got a 200 joules. Now students, I will apply magic formula. What magic formula? Basically applied force is not there. Basically applied force is not there. So when applied force is not there, so work done by applied force is capital F into D, that would be equal to 0. Now I'm applying magic formula. What is that? Work done by applied force, work done by frictional force, kinetic energy plus potential energy, because particle is traveling downwards. So this is a B for bottom, T for top. So bottom minus top is a formula. Okay, so this is 0 and this is, we know it is given by him already 50 joules. I'm going to copy 50. Kinetic energy at B at the bottom is a 10 V to power 2. And potential energy at bottom, because 0 height I consider, I got a 0. So kinetic energy on top, I got 250. And negative potential energy, I got it 200 joules. Okay, just a matter of solving. So this is a 450 goes there, 450 positive. Okay, and I'm getting here 400 and 400, I got a 40. So root of 40 is becoming 6.32 meter per second. I hope so. You got a point very well. And the question is over. Straight. A cyclist is riding, question number 3 we have, along a straight horizontal road, and total mass is a cyclist's mass is given 90 kilogram. And power is exerting 250. And in the speed at that moment is 5 and acceleration is 0.1. I think this is not a hard idea. Applied force, friction force. So net force is equals to ma. So capital F minus small f is equals to ma. But you know power formula is a force into V. So if I bring it down, so I can write it here, power by V. And rest plug in the numbers. That's it. 250. V is 5. Friction is given or not? Wait a minute. Friction is power. The value of the constant friction of motion. Okay, we have to find friction. And mass is given 9 and acceleration is 0.1. So friction will go on the other end. This come this way. So this I got a 50. 5 5s are 25. And this becomes 9. Let me check. 0.90 into 10, 9. Yes. And I got F is equals to 41 newtons. Because 90 into 0.1 is a 9. Okay. So this is done. Let's go for the next part. The cyclist comes from bottom of the hill and inclined to the 2-degree horizontal. So let's talk about horizontal. This is 2-degree. And the power given that power and resistance motion are unchanged. So power, it remains 250, 250. Power remains 250. Friction remains 41, same. All right. And what is story we have further? So, you know, students, was basically what is the rule here? Applied force, frictional force, and mg sine theta. System is moving upward. What's the steady speed? So acceleration is confirmed 0. So basic formula, capital F minus small f minus mg sine theta is equals to ma. But mass acceleration is 0. And here F value power by V. or I just save my time because it's the same. So I'm just writing powered by V. I plug in the numbers, 250, and we need to find out the speed. So V unknown, and 41 mass is 90. So 90 into 10 into sine 2 degree is equal to 90 times to 0. Okay, so I will bring 250 over V, and this other component I bring on the other side. So 900 sine 2 degree. So matter of just typing in calculator. So 41 plus 900 into sine. So I got it, 250 over V is equal to 72.4095. 4095. So this 250 divided by, and I got my answer 3.45 meter per second. So I hope so. The concept is very, very clear. And question number 4, students, we have to do. Let's talk about, he said the two masses, 0.2 into 10, we got a 2 newtons. Okay, and this is into 10, 1 newton. Okay. He says one thing, equilibrium, part in equilibrium. And let me tell you one thing. This is a 10 because these are different strings. String lengths are different from each other. And that is why the tensions are different. So let's assume this is a T1 and this is a T2, I assume. So T2, then this is a, naturally, we have a two components, a 45 degree, these are 45 degree. So, you know, when two lines are parallel to each other, a line cuts. So this is a 45 degree, this 45 degree. So this value T2 cos 45, and this value become T2 sine 45. Okay. So now, students, this force equal to that, number one, and this force equal to this. So I can make it two equations. So T1 is equals to T2 cos 45, one option, and T2 sine 45 equal to 2, because this equal to this and this equal to this. So I think, okay. So first of all, my main task is to find tension string AB, which is a T1. So first of all, I will find T2, which is obviously 2 over sine 45. So sine 45 is root 2 over 2. So if we divide 2 over sine 45, so I get the value 2 root 2. Okay. So after this value of T2, I can plug in it here. So T1 is equals to 2 root 2 into cos 45. And with again root 2 over 2, if you check in calculator. So this is cancel out and T1 becomes root 2 into 2. Root 2 into 2 gives us 2 newtons. And I believe the point is clear. So the force acting in this string AB is 2 newtons. Now, students, next part is what? The find theta value and tension is string part BQ. So make sure BQ, he talk about this tension. So I given as T1, T2, I will label here T3. I will label here T3, and now because we know this T1 and this T1 are equals to each other. So this is again 2, both are 2. So now I'm focusing on this plan and I will go for it. So what is this, student? Common sense. This is a theta, the T3 cos theta. And what about this, student? So this T3 sine theta. Okay. And now this is a 1. So 1 equal to that. I got a 2 pairs. Let me write 2 pairs. T3 sine theta is equals to 1. And this equals to 2. Okay. And T3 cos theta is equals to 2. So these two equations, I got it. And I'm going to solve them. Solve them here. Even I can solve in here, no problem. Okay. I'm going to solve them. Okay. So when I try to solve them, so first of all, you know, sine over cos is 10. Okay, 10. So if I divide them, so equation number 1, equation number 2. So 1 divided by 2, what happens? T3 sine theta up, T3 cos theta down. and 1 up, 2 down. This cancel out. I got a tan theta is equals to half. So when I take a tan inverse, so tan inverse of 1 over 2. So tan inverse 0.5 or 1 over 2, we got a 26.6 degree. Okay, basically 26.06. I'm writing a long answer. 5651. And answer finally got 26.6 degree. This is a final answer. But if I use this rounded answer in any one equation, here or here, I can get a tension value as well. So put in 1. So T3 sine theta is 26.5651 equal to 1. So T3 will become 1 over sine of 26.5651. So if I type in calculator, so 1 divided by sine of answer, so I will get my tension 2.24 newtons. So I hope so. The concept is completely clear of this question. So make sure, I repeat again, these tensions are naturally equal to each other because they are acting towards each other. You can see in same string. And due to this weight, this tension is different. And due to this weight, this tension is different. So basically, we have 3 tensions are acting on this special question. I hope so. The point is very clear. So question number 5, we have 2 particles P and Q, masses 2m and m kilogram, you can see, and held at rest of same vertical line. Vertical line is definitely means like this. And height of P and Q above the horizontal is 1 meter and 2 respectively. And P is thrown upward with the speed of 2 and Q is released from rest. Okay, so diagram is very important. As I said before, in my previous lectures, I showed you that this is, let's say, ground. And imagine this is a 1 meter. And this is a till here. Okay. And this is another 1 meter. Okay. There's a P particle, there's a Q particle. And P is a little bigger, a coordinate situation 2m, and this m. And this also 1 meter. Okay. Initially, P is thrown upwards. Okay, speed of 2. So gravity 100% negative 10. And P, this Q is downwards, so starting spot 0. And gravity with positive. Okay, this is clear point. Let's talk about what he's asking for speed immediately before collision. So we have to find the speed at this. We need a collision. So distance, this is a SQ and this is SP. So SP and SQ, if you add them, must be 1 meters. Okay, so let's start. So once I just show for the P particle and one I show you Q particle. So first of all, data writing is very, very important. I know this kind of question always harder, and how you can make it easy. I tell you, planning as data writing is very important. Gravity is negative 10. For the other one, U is 0 because it drops. Okay, and gravity is positive 10. Okay, so I think data is enough. Let's apply formula. S is equal to UT plus half GT square. Okay, same formula I'll use for Q as well. Okay, so have a look. So S is, this is called SPI, right? And U is 2T plus half into negative 10 T to power 2. SP, I'm getting here 2T negative 5T to power 2. And what about this SQ? U is 0, it's gone. So 0 and half times 210 and T to power 2 positive because falling downwards. And you know, this is a very important point I discussed many times. When particle is going away from observer, we take a positive, and when coming back to observer, we take a negative. These kind of questions we can take observer's eye on the top, or best idea, keep your observer's eye at the bottom. Okay, so this observer's eye at the bottom. Okay, so now, this is SQ, gives us 5t to power 2. According to situation, both distances, if add, give you 1 meter. So SP plus SQ is equals to 1. If I plug in this both values, 2t minus 5t square plus 5t square is equal to 1. They cancel out, and this 2 divides, and we got a half second. It means time it will take to hit the particle is a half second. And now, interesting part, he asking speed of particle after collision, or just before collision, sorry. So we have data is mentioned. I will find out the V. So V for the both particles, I'm again a division. So V is equal to U. This is for P, and this is for Q. V equals U plus GT, and again here V is equal to U plus GT. When I plug in the starting speed 2 here, so 2 times 2 gravity is negative 10, and T half. I got here negative, wait a minute, P particle. I'm getting here 2 5s, and I got negative 3. And when apply this U0, so you know it very well, 0 and positive 10, and times 2 half, I got a 5 meter per second. Now here we have a trick. Here you have to listen to me very carefully, otherwise you will not understand the question. And there's a critical point we am going to discuss now. You know, basically, a lot of concepts is here. If you will not understand this part, you will not able to solve the question further, and you will able to get only 4 marks. Next marks you can't get it. Okay, so next mark depending upon the direction of speed. You know what is this VP and this is VQ. So what is VP? VP is when it collides, its velocity is negative. But as I said that when particle is going away, velocity is positive. Now you may ask, so how is possible P is traveling up and speed become negative? So how velocity can become negative? It means this, that it means that we can say here the diagram is not a true diagram. Is not like that. Diagram is slightly like this. Look, I show you this again. Ground particle P is here. I give you this another idea so you can understand, inshallah. This is a particle P, and this is a particle Q. So particle, this is a 1 meter, as you know, 1 meter, and this is also 1 meter. So realistically, when the particle goes up and stops somewhere and comes turn down, and when turns down, the velocity was negative. That is why its velocity become negative. And there's a reason. It means when P is traveling up, they're not hit together while traveling to each other. No. Actually, if we can understand from here, P goes up and turn back, and then Q come and hits back. So it means this velocity is a negative 3, and then P will be not 5, positive 5, because Q is also coming towards observer. Look, I show the eye of observer, and or I bring this just concept. So I hope so you understood. Okay, it is very clear because we got it from here that negative. So it means P was not traveling upward when it hit with a Q. P was coming downwards. Okay, Q was coming downwards, and that is why, look, I show and I raise a point again so you can understand. So this was situation. First it went up, and then it came down. So when it was coming downwards, okay, look, I show once again, goes up and coming downwards. So then this particle hit, or maybe not even here. Maybe it is what is my approach, and you will come to know later on. Maybe they hit at this level. Okay, so this idea is okay, and now we can say that this P was traveling down and Q was also moving downwards. So both velocities are negative. So that is why I must keep this velocity also negative. So I will say that as both collide collide with each other while traveling downwards. So velocity of VP is -3 and velocity of VQ is -5. So this is a critical point, and he was asking us speeds. So speeds are positive. Speeds are not a problem. Speed, if you talk about speeds, so speeds are very clear if we make it here data. So speed of P is naturally 3, and speed of Q is 5. These are not problem. This is my final answers, and I believe you got a point of this one, meter per second and meter per second. But this data is very, very important, and this data we'll utilize in next part. So let's try to do next part. It is given that immediately after the collision, the downward speed of Q is 3.5. So I just show you situation number 1. Then inshallah, I believe you will understand this ground. Is a ground. I make 2 diagrams to understand. This is a P particle, and this is a Q particle. So this is a 1 meter, and this is also 1 meter. Okay, so first they were traveling towards each other, but when it hit, so P was okay. Now, very interesting. Because our main concern is what? After collision, the speed of the Q is 3.5. Okay, we have to apply a law of conservation of momentum, and we have to find the speed of P when reach the ground. So first of all, I will apply a law of conservation of momentum. So observer's I is, again, I tell you here, observer's I is here, okay, and observer's I is here. Is very important. Okay. Now, students, a very clear point. This is important to understand. This is before collision. This is before collision, and this is after collision. Before collision, the particle P and particle Q. Particle P is 2m, particle Q is m. Particle P is 2m, and particle Q is m. Is a P and Q and P and Q. So this P was moving downward 3 and Q was moving downward the 5. So this was moving 3, and negative direction means it is again I make it up. This is a diagram. I just make it. Okay. So this is a downwards and this is a downwards as well. Both are negative. And he said that there's a after collision, the speed of Q moving downward again 3.5. So this is again 3.5, but again negative. QP, I don't know. Naturally, we know it is moving downwards, but just say I don't know. And speed is X. So what is the basic formula? M1U1 plus M2U2 is equals to M1V1 plus M2V2. So you will see that I did not put any direction, though I know that it's coming downwards. So we'll get it automatically X. If this answer come positive, so it is going upwards. If it's coming negative, we can come to know. So let's apply before collision. Before collision, so I will write the values here. So the values are very before collision is mass is a 2m and there's a -3. So mass is a 2m into -3. And this second is a 5 mass is m into -5. Okay, what about this one? This one is 2 times 2 mass into x. And what about this one? Mass m into 3.5, but -3.5. Okay, this is -6m. This is -5m. This is a 2mx. Is a -3.5m. Mass cancel out. And I got -11, 2x and -3.5. It goes there. And if it goes there, so out of 11, subtract 3.5, and I got it -7.5. So I get an x value is naturally, x value is becoming -3.25, 3.75, sorry. And I got negative. You saw automatically speed come negative. It means all 4 directions are downwards. Okay. I hope so you got the point. And negative mentioned that coming also towards observer. This negative sign which I got it now, representing is traveling downwards. Okay, so this is a velocity after collision, this velocity after collision. So this velocity is the most important velocity which I need, okay, because we did look at here, find speed and instant which reach the ground. Okay, this is a start. This speed after collision will behave as a starting velocity for the falling downwards. Okay, student, now focus carefully. What situation? So we understood one thing from here. So P was not going upwards. P was moving downwards when it was hit. Okay, now where it hits. So let's move on that situation. So let's talk about a u. This is a P particle. This speed will behave as a u 3.75 for the P particle. Last velocity, we need to find it. And distance, this is another problem. We don't have a distance. And gravity is naturally is coming downwards, a positive, then it's not a problem. If we got a distance, question will be finished. And we can get it distance by, we want to know that the P particle, when it was traveled, it was to look at it. So if I plug in, this is a distance of P particle when it was traveling upwards. If I plug in this half in this and this, so let's see, have a look now. So I'm going to copy now, okay, and just mention here, paste here. I'm writing here 4P before collision. Before collide, okay? So SP is equals to 2 times 2 half minus 5 times 2 half. At that particular moment, I got a 5 upon 4. Actually, it becomes negative 1 upon 4. It means what was the position? Do you know, students? Actually, we start from here. P starts from here. And if start from here, this is called positive displacement. Positive displacement. Okay, and this is called negative displacement. Negative displacement. Displacement is obviously clear. So this negative displacement mentions that particle first moved this way and it coming down at this level. It was when Q hits here. So diagram is totally different. What we assumed before. Diagram is totally different. So I'm not going to explain again. So it means that particle Q was here, Q was coming downwards, and P was here when both particle hits. Okay, they hit each other. Let me show again. This is a situation below 1 meter that hit here. Okay, this is a collision. Actually, we assume collision is here, but collision is not here. Collision is here. How I know? Because this distance is 1/4. 1/4 negative. Okay, 1/4 negative. So this is how much this from 1/4 gone. So this becomes 3/4. So now P will travel how much distance to fall downwards? 3.4 distance. So that is why distance turned to be 3/4. How I got it? 1 minus 1/4 equals to 3/4. Now I can apply 2AS or 2GS is equal to V square minus U square. Gravity is positive 10. S is a 3/4. Last velocity is task to find. And U is, this is behaving as a U. 3.75 to power 2. This is 2 ones are 2. 2, so got a 15 plus 3.75 to power 2 and equal to V. So we make it root of the whole. And let me check. 15 plus 3.75 square. And I got the answer 5.39 meter per second. So now let me elaborate once again. So many students think that the collision happened in this meter distance, okay? And it was traveling upwards, traveling downward. No. We got it later on. So when P was traveling downwards, okay, and Q came down and hit, and I think you got a point. So it is, and they hit actually here, okay? And it is a slit, it is a 1.1/4 meter below. How I got 4 meter below? When I plug in this half second in a distance of P particle, and we got it. This is negative 1/4. It means it was traveling from starting point. This is a starting point. Make sure this is a starting point. So from starting point above, positive displacement. Don't forget this concept. And below this one is called negative displacement. And that is why I regularly explain. For example, if this is observer, if particle is here, displacement is positive. If particle is backwards, so displacement is negative. I hope so you got a point. And this question is completely over. So this was a little tricky. And only part is if you make the diagram properly, the question becomes easy for you. Question number 6, we have students. P travels straight line starting from O with a velocity of 6. It means when particle is traveling from O, so this O, so velocity distance is naturally 0, velocity is 6, and time is naturally 0. Because starting means when time is 0. Okay. And the acceleration is given by this formula. Okay, till 1 we have this situation. After 1 we have some other situation. So this formula is valid before 1 and this formula after 1. Okay. So he said find the velocity p when time is 1. So how to find it? So acceleration negative 1.5 t to power half. We have basically these 3 levels. Displacement, if I differentiate, we get a velocity. And if we differentiate again, we get acceleration. So by differentiating, we're getting 1 level up. Okay, differentiating. But if I want to come down, I will integrate with respect to time. I will integrate with respect to time. Currently, I am on acceleration level. I'm looking for the velocity. So I will come down, and down means integrating. So let's start integration. So if I integrate this both sides, so I get a velocity and negative 1.5 inside, outside, no problem. Increase. First I show steps. Increase the power by 1. I mean this half plus 1, 3 by 2, and 3 by 2 and plus c. 3 by 2 is basically 1.5. So they cancel out each other. And I got a v equal to negative t to power 3 by 2 plus c. And now I can put this data. So it means when time is 0, v is equal to 6. So 6, 0 plus, so c becomes 6. And I plug in back this equation here, and we got a expression, students. Expression is basically we are getting here is velocity is equals to negative t to power 3 by 2 and plus 6. This is expression I got, but he said find when time is 1. So put time is equal to 1. When I plug in 1 to power a number 1, so I got negative 1 plus 6. Sorry, velocity. So I got 5 meter per second. Alhamdulillah Rabbil Alameen. So let's go for next part. So make sure when time is 1 second, velocity at this moment is 5. Okay, we got it now. Let's move on next. There's a no change in velocity when time is 1. He's saying that when time, you can see even student this 1 and this is more than 1, but still he's saying velocity at both are equals to each other. So velocity expression from here and velocity expression from here, they are equals to each other according to the statement of question. And we define expression of velocity more than t, bigger than 1. So I have to use the lower equation now. A more acceleration is basically 1.5 t to power half and negative 3 t to power negative half. So we have to, again, we are on a level of acceleration. I need velocity. So I will integrate. And when I integrate, I get a velocity, integral sign 1.5 t to power half, negative 3 to power negative half, and dt. So increase the power by 1, we got a 3 by 2 and 3 by 2. Increase the power by 1, we got a positive half by positive half plus c1. This is basically cancel. V is equals to t to power 3 by 2. And this will flip up. And we got, because 3 over 1 over 2, it will flip up, become a 6. So 6 root of t plus c1. So you know, students, and very clear, we know when time is 1, velocity 5. We can't apply this condition because this condition applicable for the first equation. And this equation applicable for the second, that is why I'm using t is equals to 1, v is equals to 5. We know it, we got before. So v5 and 1 and 1 is a negative 5 goes there, positive 5, and I got here 10 meter per second. Sorry, there's a 10 only, there's not a expansion. And plug in back here, and then I can say velocity turns to be t to power 3 by 2, negative 6 root of t and plus 10. Alhamdulillah Rabbil Alameen. I believe The point is very clear. He said, given the velocity of p is a positive for t is less than equal to 4, it means if I make a velocity time graph, if he mentioned here, if you make a velocity time graph for 0 to 4 seconds, okay, this graph, this one, like I just to give an example, what it's saying. So whole graph is lies above x-axis. Basically, when a graph goes up one positive, below is a negative displacement. So, but he said it is a totally above, so it means when if a negative comes, we have to be careful about this negative sign. But now we have no care about it. Reason because full graph lies above x-axis. He mentioned. So velocity is positive. That is why. So how to get a total distance traveled between 0 to 4 is asking for how to find distance, and we are confident about this plan. Again, velocity displacement, I have to integrate once again. So what integration we have to do it, students? So first expression is this. We have to integrate, copy, and I'm going to paste here. So this is the first expression, and second expression, we just got it now here. And we have two expressions which we have to integrate to get the answer. So let's go for the first one, and this is 0 to 1 and negative t to power 3 by 2 plus 6 and dt, plus this is 1 to 4 and t to power 3 by 2 negative 6 to power root or half, same meaning. I hope so. The point is very clear, and we got two expressions already available. Okay, I'm going to use now. Okay, so what is the way? Increase the power by 1. So we got this is already half. This is a 3 by 2. Increase the power by 1, 5 by 2 by 5 by 2, and 6 becomes 60. The limit is 0 to 1. Plus, what about this? Is a 3 by 2, add 1, so 5 by 2 by 5 by 2. And negative increase, so 3 by 2 by 3 by 2. And 10 becomes 10t. And 1 to 4. Simplify before you plug in the limits. This 2 will go up, and I got it in bracket negative 5, 2 over 5, sorry. And power is a 5 over 2 plus 60. Simplification is very important. Otherwise, a lot of risk of mistake. I think this part is clear. This 2 will go up 12, and 3 4s are 12. So we got a 4. And power is 3 by 2 and plus 10t. Okay, student, now I'm going to plug in one by one. When I plug in 1 in the both values, what I get it inside 2 by 5 plus 6. And no need to put 0 because I will get definitely 0. And plus, what about this? Replace everywhere 4. When I replace everywhere 4, let's see what happens. So let me check in calculator. 2 divided by 5 in a bracket 4 and power 5 divided by 2. And then negative 4 times 2, 4 to power 3 divided by 2 and plus 40. And I check it, I got a 104 over 5. Upper limit done. Now I'm going to plug in 1. When I plug in 1, so I will get this number, and this number. So 2 by 5, negative 4, and plus 10. I'm getting here 32 over 5. So negative 2 over 5 plus 6. I got a 28 over 5. And what about this 104? 104 divided by 5 minus 32 divided by 5. I got a 72 over 5. And 28 plus 72, if I check it, I got 100, and 100 by 5, I got a 20, because meter, so meter distance, because we're looking for the distance. So alhamdulillah rabbil alameen. I hope so. The concept is very clear. And let's go for next question. Question number 7 we have, students. And but the question A, mass is a 0.2, B, mass 0.3. Okay, it's a clear. And afterwards, he said that theta is 7, sine theta is 0.6. Okay, let me write this data. It's very important. Sine theta is equal to 0.6. Okay, P, okay, the height is 0.25, you can see from here. And further coefficient friction is 1.125. So mu is equals to 1.125. And P start from rest, so this velocity is 0. We need to find tension and find out the acceleration, the particles. So student, let's start. First of all, this is into 10, and I got it. This is a 3 newtons acting downwards, and tension towards pulley. Tension will be towards pulley. But what about this particle? Because what mass 0.2 into 10, 2 newtons. So this is a 2. Actually, the formula is mg sine theta. You know it very well. Let me elaborate. Mass is 0.2, gravity is 10, and sine theta, we have a special value, which is a 0.06. So if I apply 0.6, so this weight component is acting what? Let me check. This is 6, 1.2. We got this 1.2 weight component. I believe this part is very clear. Okay, and friction is acting backwards. And how to find friction? So actually friction is F is equals to mu R, and mu is 1.125. And R is what all of you familiar. This is a R, and this downward is mg cos theta. And basically mg cos theta, m is what? M is 0.2. Okay, let me find it below here. Okay. M is 0.2, gravity is 10, but problem cause I don't have it. So I use it here. And what is the formula? Basically, cos square theta is equals to 1 minus sine square theta. Take a root of the whole thing. It becomes 1 minus 0.62 power 2. And when we check in calculator, it gives you 0.8. And 0.8 comes here, so 0.8. And it comes, this is a 2 to a 1.6. So we got a 1.6. So R is 1.6. So I believe this is very clear. And friction force, which I'm getting finally, is 1.125 into 1.6. And my answer is turned to be friction force 1.8 newtons. All right, this is a clear. Now, students, we have to make two equations, one for the B particle. B particle, so how many forces acting? So naturally, this is falling downwards. So this 2 is bigger, tension is smaller. And basic formula, we have net force is equals to MA. Because this bigger, the smaller, so 2 minus T is equals to 0.2A. Same way, if we go for A equation, so how many acting force A? If you check it, tension, weight downwards, and friction backwards. So I can say tension, again, same formula, net force is equals to MA. So I can write weight component 1.2. And what is the next one? Tension also adding, or just write start from tension. So tension plus 1.2 minus friction force, which is a 1.8. You can see from here, equals to mass 0.2A. So if I check this one, so I get what? This I'm getting T negative 0.6 equal to 0.2A. Equation number 1 and equation number one was that. This equation number 2, I bring equation number 1 down. I think this is a mass 0.3. Sorry for that. So B particle point, this is a not a 0. Oh, sorry for that. It looked like a 2. So I have to make it 3. Thank you. On right time we saw. So 3.0.38. Okay, I wrote such a way it looked like 3. 2, sorry. Now it's 3 clear. Now I'm going to start. And what is the method to start? So students, this is a 3 minus tension equal to 0.3A. Equation number 1 came from there. Tension cancel. Out of 2. Out of 3.6 gone, I got 2.4, and here 0.5. And if I divide this down, so 2.4 divided by 0.5, I'm getting 4.8 meter per second square is my answer for acceleration. This value, I'm going to plug in it here, okay, or I can plug in this place. So put in 1, so T minus 0.6, 0.2 into 4.8. And if I check it, so 0.48 into 0.2 and plus 0.6, and answers turn to be 1.56. So we got a tension 1.56. Over. Student, let's go for next part. Next part, we said when B reaches the ground, it come to rest. So when B reaches the ground, it means when B will fall down, falling down, and will rest. Okay. And when rest, this tension will become zero. So no pull will be there. Okay. When no pull will be there, so maybe this particle will slow down and maybe stop somewhere here. So read a further part. Find total distance air travel down the plane when it still come to rest. We saw it come to rest, assuming A does not reach the pulley. So situation we have what? B will fall down. So I tell you plan of action. What is the plan of action? So B, let's talk about the B part for B. So U is equal to 0. Acceleration, we got it on top, 4.8. 4.8. And S is how much to fall down? You can see S is 0.25 to fall down. S is 0.25. And we are looking for two things. I think one thing V, where is very important. 2AS is equal to V squared minus U squared. You may ask what's the reason we are finding it, although he is not asking to find V squared minus U. So when I take a root of the whole thing, so root of 2 times 2, 4.8 into 0.25, and I get it in root form, 2 root 15 over 5, okay, or decimal format 1.4592. You use the first one or second one, but I use the first one for more accuracy. All right, very interesting part. When it is a traveling downwards, students, so this particle is traveling this way. So it is the last speed of this particle will become, because it will move in two stages, okay? One stage, it will move to the same distance, 0.25, look I show in diagram. So you will understand when this particle will fall down, I think the B, it will move 2.5 meters. So this, let me show you the other plan, other diagram. So for the A particle, it will move in two situations. First, it will move this much, and that is exactly equals to 2.5 meters. And then if we move further, we don't know how much this to move further. This is my task. Okay, an interesting point which we have. So what is just before hitting, what's the last velocity here? That is a 2 root 15 over 5. And for your knowledge, because here speed is 0, it's a traveling the same speed. So it means last speed of this equal to last speed of this. And that is the last speed. I'm writing V equals to 2 root of 15 over 5. And this last speed will become starting speed of the next stage. U equal to root 15 over 5. So I'm repeating. After B hits. So what now I'm talking about A particle. Okay. So what after hits? So this U is 2 root 15 over 5. Ultimately, it will stop. So last velocity is 0. S is my task, but problem, I don't have acceleration. So for acceleration, I will concentrate again. These kind of things, when inclined plane comes, this is what, you know it very well. 2 force acting tension and mg sine theta. And backward is a friction. But you know, when this particle will hit, we will hit, tension will become 0. So it means tension becomes 0. So basically, I'm using weight component minus friction equal to, and friction, I got it on the top, 1.8. Check it again. Friction, I got 1.8, and weight component, I got it 1.2. mg sine theta remains same, 1.2, and friction is 1.8. So basically, we have our 1.2 and 1.8. So I'm going to show you. So this is basically 1.2, and this is 1.8. So net force is equals to MA. So 1.2 minus 1.8 is equal to 0.2A. This is becoming 0.6, negative 0.6. It divides, I got a negative 3. So alhamdulillah, I got it. Now I can apply 2AS equal to V squared minus U squared. Acceleration, negative 3. S is a task. And last velocity is 0. U is this. And this is called motion due to inertia concept. Is negative 6x. And on the other end, if I take square of it, I get a 12 over 5. This is S 1205. And distance become what? 1205 divided by 6. And I got a 0.4 meters. And total distance, how much? So total distance is travel until stops. So before it travels, look at here, it will travel 2.5 meter and will also travel 2.5 meter, and this 0.4. So Alhamdulillah Rabbil Alameen. So 0.25 and 0.4. 0.25. So I got 0.65 meters distance to stop the particle. I hope so. The concept is very, very clear. And the question is completely over. And paper is completely over. And best of luck for the exams. And best technique as a teacher is just to reattempt those questions where you done mistakes. And especially this question, even every question you see, that data writing is so important. Data writing so important, diagram making so important. And especially this question, what is the technique? You have to make a full diagram time by time. Okay, and in this special, we have velocity signs are very, very important. You have to fix observer's idea and then try to solve a question. I believe, inshallah, you will able to solve the exam, inshallah, easily. Best of luck. Assalamu alaikum wa rahmatullahi wa barakatuh.